Good morning, good afternoon, or good evening, and welcome to the next episode of Numbers with Nando. Today we are learning how to fit an exponential curve to 2 points. Okay, so we've got 2 points there, A and B, all good. We'll just use 10 as our base, and everything I'm going to show actually works for any base, but we'll just do 10 to the power of x. It'll work well with logs a little bit later on. Now, what you'll notice here is the inverse of the log function. Our log function went through 1, 0. Our exponential goes through 0, 1. So, and it has an asymptote on the x-axis at y equals 0. So first thing we're going to want to do is to shift our graph upwards. So our first point goes through y equals 2. But our asymptote, we want to be 1 below that point. So I want to shift my graph up by 1. Cool. Now, this point here is now at 0, 2, which is good, but we need to shift it across by 4. Okay, so we've got it through the first point. We've shifted it by the x value, and we've shifted it by 1 less than the y value to account for the asymptote. All right. Now, to make it go through this other point, 9, 5, I'll just make a copy of that graph so you can see the original one. We want to find the value for m, gradient. And as usual, we're going to substitute in our points. The other point, sorry, the other is a y value of 5. 9. Rearrange it for m. Take away 1 from both sides. 4. 9 minus 4 is 5. Okay. The inverse of an exponential is a log, so I just need to take the log of both sides. So I just get log of 4 equals log undid the exponent. So finally, rearranging, we're going to divide both sides by 5. M equals log 4 divided by 5. And we are done. Oh, good. I'll get rid of that original one. And there you can see the working below, which is very cool. But wait, there's more. Let's think about what happened. What did we do? Shifted x by the first x value. Let's just call it x1. So I'm going to make up some points in a second. x1. I'm going to make up some points in a second. But we shifted it by the first x value, which is x1. And we moved it up by the first y value. But we took away 1 to account for the asymptote. Instead of moving up by 2, we only moved up by 1. So instead of moving up by y1, we're only going to move up by y1 minus 1. And so, for example, I've got a little point here called P1, which is at x1, y1. Going through the point, I'm going to get rid of these other things and those labels. Okay, so I've made a new point. And if we slide it along, it's all good. So I've made my exponential curve go through my first arbitrary point by shifting it by x1 and shifting it up by y1 minus 1. Okay, so now all we actually need to do is change the slope. If we think what happened, how did we find the slope? This value 5 was just 9 minus 4. That's how we got the 5, became the 5, and landed on the bottom. So we got this 5 here by finding the difference between the x values. So the difference between the x values of x2 minus x1. I'm going to make a new point called p2. And where did this log of 4 come from? Let's think it was 5 minus 1. So the second y value, take away the first y value, take away 1. y2, take away first y value, take away 1, which is just first y value plus 1. And that's how we got the log of 4. Was this the difference in the y values, but plus 1. So let's make these new sliders. I'll just move them below. I've got some new point P2, which is at x2, y2. And I am hoping that my exponential curve goes through that point. Okay, what I need to do is make sure that my I was going to start from my bottom point and go up, so I just need to make sure that my second y value is greater than my this is not going through the point, so let's figure out what we've done wrong. I've got the difference in the y values, difference in the x values. All right, let me jump to one that I have previously done, see what's gone wrong. There's what I've done wrong. Okay, well spotted, everybody. Okay, in the original equation, it was log of the difference between the y values. That's the gradient, the log of the difference in the y values. Okay, there we go. Now I can play. So we've got the second point moving around and the exponential curve is adjusting to fit through it, which is very cool. So this here is the general formula for an exponential through any arbitrary point.